So for number 1, it's going to come up on the screen here soon, hopefully.
I don't know how to do it.
How?
No, Eli. What's your guy?
That actually is not a terrible method.
Eli divided them up into fifths.
Yeah.
And then counted the blocks.
Eli counted the blocks, which is not a terrible method.
It's the worst method.
You pretty much can take this little piece right here and put it down here. So you got 1, 2, 3, 4, 5. Yeah. I put these two together, that's 6 whole blocks. 6 times 25 would give you 150. Plus you got some extra space up here, so you know it's got to be more than 150. But what is most important is that you know that you're supposed to find the area under the curve here. So it's giving you B, which is your measured in people per minute. So this is the rate. This is not the number of people, but the rate. So you need to integrate underneath the, find the area under the curve, which is integrating here. So you could just do that, or you could break this up. I wish it would let me write right here. So if you break that up, you're going to have a trapezoid. So you could have 1/2 times 15 times 5 plus 15, which is going to be, this is going to be 20, take half of that is 10, so that gives you 150 alone, just that part. And then the triangle here would be 1/2 times 5 times 15, which is going to be 37.5, but this is calculator inactive. Just by process of elimination, you could decide that it's D there, if you don't want to do all that by hand. The 5 plus 15 will give you 20. Half of 20 would give you 10. So like you'd have 1/2 times 15 times 20. So I did the half of 20 first. So you got 15 times 10. And then that'll be 150 for that first part. And then you would also need this triangle over here, which is the 37.5. Does that make sense? And it's going by 5s. Yeah. So make sure you're counting by 5s instead of by numbers. That's why they've got 15 and 38 right there. It's because you might get those answers if you don't pay attention to the scale. Yeah. So if you got A or B, you probably were just counting your blocks like each one is 1 by 1, but they're really 5 by 5 there. Okay, other ones you guys have questions on. I know somebody was saying 12.
Yeah, 12.
Okay.
Just like solve it.
All right, 12, you got to integrate. Yes, you got to integrate, find a C, and then integrate again and find a C. So when we integrate this, it's going to give us velocity. To integrate 12e to the negative 2t. Not quite. It's not going to be negative 24, although you are at least paying attention to that negative 2. Negative 6. Because your u, when you're integrating this part right here, your u is the negative 2t, which means your du needs to have a negative 2, which, I mean, there's not a du here because it's not a differential equation, but so we would have to, like, add the du would be right here. We'd have to add it, or dt, sorry, would be right here. We'd have to add the negative 2 here, which means we'd have to put a negative 1/2 out front, which would give us negative 6e to the negative 2t, plus we'll have, make sure I'm doing that right, 9t squared plus c. Correct, yes. As long as you don't have something weird like a 2t squared or something, or a square root of t, then it would be much different, and probably, you're probably not going to see that, though, because it's probably not something that we can do without a calculator. And if this were calculator active, we could just use the calculator. Let me make sure I'm right up to this point. Yes, okay. So we want to now plug in our information. So we know at t equals 0, we know that velocity is 2, and we know that the position is 4. So we're using 0 and 2 right now because we've got our velocity equation. So 2 equals negative 6e to the negative 2 times 0 plus 9 times 0 squared plus c. Be really careful here because I may have heard Addison say c is 2. Because when you're plugging in those zeros, you make that assumption everything goes away. This goes away, but e to the 0 is 1. So you're going to have 2 equals negative 6 plus c, so you're going to get 8 for the c. And so if you didn't get the correct c here, it's going to mess up your answer at the end. So we got negative 6e to negative 2t plus 9t squared plus 8. All right, from here, what should we do? Integrate again. So our x of t for position, this time we're going to get 3e to the negative 2t. It's that same principle that we used before. You're going to have the u. You're going to have to divide. You can if you want, but we're integrating it.
You're integrating velocity dt, or what? You're integrating the velocity to get position.
Yeah.
So integral from what? Is there any range that we're doing that from?
No. No, these are, when you get the plus c on the end, that's just your general solution.
Oh, yeah,
so you don't have those that you're plugging in. So we'd have plus, here we're going to get 3t to the third plus 8t plus c. And so from here, you need to find, you're going to plug in 4 and plug in your 0. A lot of times, not always, but especially with the exponential, they almost have to, because if they don't, you'll have an equation you can't solve. So, so we'll get 4 equals 3 plus c this time. So 1 is our c, so x of t is 3e to the negative 2t plus 3t cubed. I realize there's not nearly enough room there to do this. And so the last thing you would do, they ask you for the position at t equals 2. So you just plug 2 into this equation. So 3e to the negative 2 times 2 plus 3 times 2 cubed plus 8 times 2 plus 1. So this is going to be 3e to the negative 4 plus, let's see, that's 8 times 3 is 24 plus 16 plus 1. So 3e to the negative 4 plus 41. And that is C. These were problems that they gave as topic questions for this unit in AP Classroom. I feel like this is the upper limits of what they're going to give you on a multiple choice, because that takes a long time to do. And if every question was like that, it would take you forever. So there might be a better chance that you'll see something like that on the free response, really, than the multiple choice.
Do you think the packet gets progressively harder?
I mean, in the real test, yes. On these, I don't know. I wouldn't necessarily say so here, but on the real test, they do try to put some of the easier ones at the beginning, and the harder ones towards the end. So
when we do our test, like our simulation test, what's the end of the will it be easier starting off?
Yes, because whenever I give, I've got 2 more complete release tests that I want to use. We're going to do one of them as a test grade. We will do one as like a review, and I'm hoping for time to do one more, but I've got 2 that are like released from AP that are entire tests that I don't even have to worry about if they align because AP made those tests and put them out there. So, yes, so we'll have a test for Unit 8, and then we will have a test which will be like our mock AP test that we'll take, which we may do another one in class, not for a test grade, but there will be one. The last one that we do before the exam, it'll be a test grade. Yes, and then if you have to take it, the teacher made exam. So for 8, when we're given a velocity function, and they give us the initial position, and then it says, which of the following gives the total distance the particle travels from 0 to 3? So we've talked about this a little bit before, but I wanted to mention it yesterday, and then I forgot about it. So we've talked about this a little bit before. If I graph this, I'm going to graph this on Desmos. It's not calculator active, but I think it helps to look at it for the general understanding of this. If I graph this, y equals x to the third minus 3x squared plus 2x. So if I graph this, and we're looking from 0 to 4 here, 4 goes way up pretty high. But if I graph this, my velocity was positive, and then it was negative, and then it was positive again. What does velocity tell us about how the particle's moving? What? It tells you whether or not the position is increasing or decreasing. And so if we're talking about a particle moving along an axis, increasing would mean moving to the right, and decreasing would be moving to the left. So what happened here is this particle went to the right a little ways, then it went back to the left a little ways, then it went to the right for a pretty good while, right? So the total distance that it traveled would be, all of those distances added together. The problem is if we just integrate this from 0 to 3, then it is going to count this section as negative. But that's still distance that you traveled, right? I used the example with Ethan that if Ethan was supposed to go to the front office, but in typical Ethan fashion, he goes down to ROTC first and then he goes to the front office, just wandering around. So if that happens, his displacement from the office is just a distance from here to the office. But his total distance traveled is much greater because he had all that distance that he went where he wasn't supposed to go and then back. So if you are looking for displacement, you just integrate the function. But if it asks for total distance, you want to put absolute value bars around the function. What that does is it takes all the negative parts and it flips them back up and makes them positive. So all those areas would be positive, even if they were in the wrong direction. So if you see total distance, throw some absolute value bars on that to integrate. If you see displacement, then you do not want absolute value bars. You want those negative parts to count negative. Okay, and whether or not to put the 4, so this one is wanting to know the distance from a time to another time. So in general, if you see it on an interval from this time to this time, it probably only wants you to just integrate and not add that initial condition in. If they had asked us for the position of the particle, then we would have to consider that it starts off at 4 there. But this is just wanting to know it started at 4, and then it went to the right some, left some, back to the right. We just want to know how far away it is from its starting position so we don't include that 4 there. Yeah, and 11's pretty similar. They're really the same idea there. So I bet, did you have B for 11 as well? So same idea there on number 11. All right, other questions? Okay, we are going to do a section even though we're missing several because time is so short. So this is a section that is relatively easy and usually students grasp it pretty well. So let's see. So let me pass this out. It is, I think, it's the Thursday of that last, not the last week of school, but the second class of school, I think. All right. Okay. So, the idea that we'll be looking at here today is finding area between curves. And today everything's going to be expressed as a function of x, so that means we'll be dealing with x. As we will see tomorrow somewhere we're in terms of y, so it'll be a little bit different. But I want to find the area between these two curves right here is what I want to find. So, and that is from 1 to 5 right here. So if I'm looking to find the area between these two curves, any idea about how I could do that? I could count the blocks. That'd give me a rough estimate. So but if I want to know exact.
Find the area under the curve of the red one, and then you subtract the area under the curve of the blue.
Exactly. So what's going to happen here, if I find, let me color code this here. So if I do the area under the curve from 1 to 5 of f of x dx, that, I'm going to highlight here, this part would be all the way down to the x-axis, this right here. Just 1 to 5 because they put these dotted lines right here. So you're looking at that x-axis to see where you get those values. And then if I subtract the integral from 1 to 5 of g of x dx, which is that blue graph. I realize it's not blue on your paper, but let's use green for that. So I'm subtracting this area right here under the curve. That will give me the area that's now just yellow, right? So it'll give me the area between the curves that I'm looking for here. It'll give me this right here. So, students usually do pretty well with this. It's just integral of the top equation minus the integral of the bottom equation, right? Because it's going to take that total area under the top curve and then it'll subtract out the area under that bottom curve. So let's look at an actual example where we're going to actually get a number for our answer. A lot of these you're going to have to like picture the graph yourself. So I put a graph here so we can actually graph this. If we have x squared plus 2, that would look like this. And then we've got y equals negative x. So y equals negative x would have a y-intercept at 0 and a slope of negative 1. I realize the scale on this is a little bit weird. Look like this. And then I've got x equals 0 and x equals 1. One of the biggest things that messes students up here is vertical and horizontal lines. Are these two vertical or horizontal? vertical. So x equals is vertical. So the x coordinates are all 0 right here. And then the x coordinates are all 1 right here. So those are vertical lines. So if I graph all 4 of those lines, the section that is bounded there would be this area right here. So, if we want to find the actual area of that, then we can integrate. We're going to look at the x-axis for our limits that we're going to use because we're integrating with respect to x. We could integrate from blue. Integral from 0 to 1 of the top function, which is x squared plus 2, minus the integral from 0 to 1 of the bottom function, which is negative x. So what happens is you do get a negative area right here when you do this integral, because the second part here, right here is actually this negative area. But if you just always do top minus bottom, it will work out, because what's going to happen is this is going to be a negative area, but you got a minus sign right here that takes care of that negative, right? So negative, negative will become positive, and it'll add that green area and that yellow area together to give you what you're looking for. So, so it should always work to do top minus bottom there. Now, you can integrate this separately like this if you would like, or because they have the same limits here, you can put those together. So that would be the integral from 0 to 1 of, you're going to have x squared. This negative and this negative right here will cancel out, and you'll get a positive x plus 2 if we combine those together. And so to integrate here, we're going to get x to the third, 1/3 plus 1/2 x squared plus 2x. And then we'll integrate that from 0 to 1. And we'll have 1/3 times 1 cubed plus 1/2 times 1 squared plus 2 times 1 minus, here you'll have 1/3 times 0 cubed plus 1/2 times 0 squared plus 2 times 0. So we get 1/3 plus 1/2 plus 2. And then this is just going to be 0. It was just one of the little ones. It wasn't. I thought it sounded like something just a typical middle school boy would be going down the hall doing. So. Next year, I think they're going to send the 6th graders over here to do, like at the end of the day, they're going to get on a bus and come over here and do encore classes over here. They actually don't lose much time because they'll, like they get out at 2:35 over there. They will get out like our time over here.
All the 6th graders will.
So, yeah, so
Okay.
they will get out at like 3:10 over here. Yeah, Hunter will be in 6th grade next year, so that'll be him going down the hall making that noise, and I'll have to. He'll be here sooner than I anticipated.
So they're gonna have to come pick up their 6th grader at the middle school.
Yes, if they are Carline, they'll pick them up in middle school. Yeah, they'll do it like Mr. Bashir's. So they won't have like, that's the plan that they presented to parents anyway, unless something changes. Some parents we're not super happy about it. it'll be good for us because, like, he'll get here sooner than he did before because he gets here at like 3:20 now. He will be doing something productive for that extra 45 minutes instead of riding a school bus, which we all know is not productive. And I think he'll just enjoy doing it. I think it'll be good. So we're excited about it, but not everyone is, I don't think. So why do you not have to put the plus c? So when you're doing a definite integral, you do not have to put plus c, because if you did, you would have a plus c right here, and you have another one here, and then when you distribute that negative, they just cancel each other out. So for definite integrals, you don't have to put the plus c. But if you did, it wouldn't hurt because they would cancel each other out. So 1/2, 1/3 and 1/2 is 2/6 and 3/6. So 5/6. So let's just go ahead and do our 2. So 2 would be 12/6. So we would get 17/6 for our answer here. Now, you certainly could see this on the AP exam. This would be fair game where you would have to do that little bit of fraction work there. That wouldn't be uncommon to see on your homework tonight, because I don't want you to spend an excessive amount of time just simplifying. If you want to use your calculator once you get to the plug in the numbers in part. Don't use it for integrating because they're going to be ones that you need to be able to integrate by hand. But if you want to use your calculator when you get to this part, that's fine. Okay. Yes. So this would be used for like finding areas of shapes that are very odd. So if there was, some sort of area that you need to see here. Another place this shows up a lot is like maybe this first line is your rate that cars enter a parking lot, and the bottom line is the rate that cars are leaving a parking lot. Yeah, so if you want to know how many cars are still there, you could take the top and minus the bottom there. So that will be one of the applications we'll see out of this. Yeah. All right, so find the area bounded by the graphs of f of x. I think that's not supposed to say and. I think that's supposed to be an equal sign. It's got to be. I don't know what I was doing there. Okay, so I know that 2 minus x squared is going to be an upside down parabola that looks like this. I also know that g of x equals x is just going to be a straight line that looks like this. What I'm not entirely sure of without graphing this really well is where these are going to cross. So I could just try to do a much better graph than I've done here, or they will cross when they're equal to each other, right? So if I take 2 minus x squared and set it equal to x, then I could move everything to one side, so I'll have x squared plus x minus 2. And I could factor. And so I will get x equals negative 2 and x equals positive 1. So that would mean that we're crossing right here at positive 1 and over here at negative 2. So that would tell us, it doesn't give you your y coordinates, which you don't need anyway, but it's telling you those intersection points right there. Okay, so if we want to integrate this, we would be doing the integral from negative 2 to 1 of the top function. Which one's top function here? 2 minus x squared minus the integral from -2 to 1 of the bottom function, which is just x. I am going to, on the next problem, I'm probably just going to write them together from the beginning, but I want you to think about those separately here. So this is just going to be 2 minus x squared minus the x there, if I combine those, which I can do because they have the same limits. And so we will integrate this. Whenever we integrate, Logan, what will we get when we integrate that?
2x first, then get 1/3 x to the third,
Good.
and then 1/2 x to the second.
Perfect. And then we'll put our -2 to 1 here. So this is what I'm talking about. It's okay with me if on your, let's get the other calculator. If you grab your calculator for this. And I know that Desmos sometimes is better than our calculator, but I would encourage you from here on out to avoid Desmos when possible, because you can't use it on the exam, and that will get you more comfortable with using this calculator here. So we're going to have 2 times 1 minus 1/3 times 1 minus 1/2. I'm going to go ahead and hit enter and get that part, so I just plugged in 1 to get 7/6. And then I'm going to plug in my -2. You can do it all at once. It's just really easy to mess up the parentheses if you do it all at once. So messed it up. Need a third power right here, don't I? Alright, so I got minus -10 over 3, and then if I do 7/6 minus -10 over 3, we're going to get 9/2. That's our answer. On the real AP exam, of course, it'd probably be calculator inactive, and you'd have to calculate that. But
so, like, how do you know what area is bounded by the two curves? Like, what if they just like crossed at like multiple points and they did all?
Tonight, you're not going to see some that cross at multiple points, but we will look at that. But you're just like a step ahead. All right, so everything I give you tonight, with the exception of one problem that's a little bit different. I'm not going to tell you about it. I want to see if you guys can figure it out. There might be one that's a little tricky. But everything I'm going to give you tonight will just have like a top function and a bottom function. So it'll be, this is bounded by that region. That's the only enclosed area you would have here. So that's all we'll see tonight. We will look at ones where there's more than one intersection point, but just not today. All right, tell me really quick. Yeah. That makes me so excited whenever somebody actually uses their math for, I get my, I love it whenever you actually use something there. It's great. I also love that she remembered it, and I can't believe that she's married and doing what. Even though I like Dylan a lot, it's just a little bit of a surprising couple. there. All right. I need to know exactly what it was. She might have to. I'll tell Coach Wood to ask her when he sees her. We won't. Yeah, we won't get Dylan involved. He'll see her, I'm sure. All right, so Dylan's not bad, but Dylan's handwriting was a major issue. It caused him to miss math problems, but not because he didn't know how to do it. Sometimes it was just like he couldn't read the numbers that he'd written down. Between him and Hunter Simmons, I think so. I don't know if I had them in the same class. Maybe I did. I had them at the same, like right around the same time, and trying to grade their work. Yeah, both of them are. Yeah, yeah.
What about mine? Is that bad?
You're not quite dealing with that, but just a little bit. I've told you guys before. I have a cousin. His name is Landon. He is in a wheelchair. His hands is from his knees down and his elbows down. He has like a condition where his nerves are not right, so his hands look like this right here. He cannot straighten his fingers out. His hands look like this, and his feet and legs don't work right either, so he can't walk. So to write, he has to take his pencil and sort of like prop it here. And he takes one hand and rests it on the other and writes like this. And his handwriting is much better than yours, Noah. You with two fully functioning hands. So. Even though, I mean, you know. Alright, so, let's get back to this. Alright, this type of problem, you're going to have a couple of these that you have to do as well. It gives you the integral that's already set up. And you're supposed to sketch a graph of the region whose area can be found by evaluating this integral. So, it's pretty simple, actually. It's just this right here. That is your f of x function. And this part right here is your g of x function, which if this is set up correctly, that f of x should be on the top. So if you graph it, this is just a line, so it's going to be 5. And then we'll go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. And that's probably enough because you're only integrating from 0 to 2 here. And then for your g of x function, that is a quadratic. It's moved down 3 units. But it's a smiley face. It's a smiley face parabola. Your x squared is positive. Because this negative in between is because you're subtracting the two areas, so it doesn't go with this function here. So you may remember I've done less and less with like actually graphing by hand, so you might not remember exactly how to graph that, but you can just plug numbers in. So if I plug in 1 squared minus 3 was give me -2, so there's your point right there. If I plug in 2 squared minus 3 gives you 1, so there's your point right there, and here's what you're looking at. It's going to go back up over here, but you're only integrating from 0 to 2, so you'll have a line at x equals 0, and you don't really need the line at x equals 2 because you got that intersection. You could put it there if you wanted. So we would be looking at this area right here. So you'll have a couple tonight where you've got to like sketch a graph. They should be fairly simple graphs to sketch. They won't be terribly
How do you
difficult.
know what shape you're finding? How do you know the yellow? Like, I know the 0 to 2, but is it just where it fills in?
The space between the two lines.
The space between 2 lines from 0 to 2.
What about behind it?
Over here, we don't go over here. because it tells us only to go from 0 to 2. So on the x-axis, we're putting us a vertical line at 0 and a vertical line at 2. Although the one at 2 is not entirely necessary because they do cross right there, but it's definitely necessary right here.
Would we ever need to know behind the...
If it was integrating from a different point, so if it was like from -2 to 2, then yes. But we know I could have actually started this by putting the 0 and 2 here because we're only looking in that section.
So the integral values will always be x values.
Yes. Today. Yes.
What?
Today.
What?
Today they will always be x values.
So you can like only find a strip of like, if they give you like a giant area, would you only find like the strip of
Right.
Okay.
Right. So like it'd be possible on this one to just integrate from 0 to 1, and then you would only be finding this area right here if that were the
Are
case.
we recording?
Yes. I didn't. I was going to cut it off for the story time, but I don't think I ever did. I don't ever really go to Jersey Mike's, but it is probably a little better. It's also more expensive, so.
What subway are you in?
It's there.
I go to Subway.
Jersey
Like,
Mike's subway?
Okay.
I get like the crazy spicy Subway sometimes. I just go all out. It's the best.
I probably use Subway more often.
I know.
All right.
I think I like it.
Example 4. The sine and cosine curves intersect at infinitely many places. Find the area of one of the regions bounded by f of x equals sine x and g of x equals cosine x. So, we've got to remember for this what sine and cosine look like. Okay, sine starts at 0, and then right here at pi, it'll be back down to 0, and then it'll do like this. We really won't need that last part there. Cosine, where does it start?
Next value.
Start to say,
So,
pi it goes up.
so cosine
It goes the opposite.
begins at 1, and it's going to decrease. Where is it going to hit the x-axis right here?
Between pi and
Pi over
the
2.
origin.
Which is pi
Half.
divided by 2. So we will integrate here. Then, let's see, our lowest point will be here. I'm trying to make them look kind of the same.
-1.
And then we'll go back up here. So the area in between here is this area.
On the integral on the integral pi over 2 to pi.
No, pi over 2 would be this point right here.
Yeah. Oh, wait. Yeah.
We need to know this point right here to this point right here, which we don't have. You need to know which one's on top. So, assuming this is calculator inactive, you would need to know which one is on top. And you also need to know the intervals. So, we could think about the graph in a little bit more depth, or we can think about where sine x equals cosine x. And so this first one right here would be pi over 4. Where's the next place that it equals
2 pi
each
over
other?
4?
It's in the, not in the third quadrant, because right here you have different signs. You got -√2 over 2. It's right here. I'm sorry. Yes, my mind went with second quadrant there. Third quadrant, yes. Third quadrant right here at 5 pi over 4. So we would need to integrate from pi over 4 to 5 pi over 4. And then the top function is my sine function. The bottom one is cosine. I'm going to go ahead and write these together instead of writing that separate integral. You guys okay with not writing that step
Yeah.
there?
But how do you know? So looking at the graph, the top one is sine. So like, what do you know? Do we
So we're looking at this just for that yellow area, right? So starting right here, the blue graph is on top, which was sine.
Oh,
We won't look over here because that's not where our yellow area is at. So to integrate sine, we will get negative cosine of x. To integrate cosine, we will get sine of x, and we will evaluate this from pi over 4 to 5 pi over 4. So we'll have negative cosine of 5 pi over 4 minus sine of 5 pi over 4. That gives us that first part. That gives us square root of 2. And then plugging in pi over 4, let's go delete those 5s right there. We get a negative square root of 2, so negative square root of 2. And so that would become positive. We would get 2 square root of 2 for that answer. It probably wouldn't hurt us to try to do that one by hand, but time is short. Okay, so questions, you guys get the idea? All right, the homework looks longer than it really is. 1 through 4, these just want you to set it up. You don't have to solve, so do not solve. And it gives you a graph also, so it should be pretty simple to set up. Those should take seconds to do. 7 and 8, these are the ones that are going to be where you sketch a graph. So like example 3 that we did where we were just sketching that graph based on the integral that it gave us. 19 through 25 are the ones that you actually have to work out. You may use the calculator to do that last part on those, so that will hopefully speed it up for you a little bit. I was going to do a problem from the midterm review, but I would rather you guys have a little time for your homework, so just go ahead and work on that. We're never going to get those midterm things done.